Hi, in this video I explain you the Fermat's small theorems. Fermat's small theorem explains that you have a number powered by a primary number minus the first number is divided by the primary p number. Example, you take 2 to power 5 equal 2 by 2 by 2 by 2 by 2 equal 32. 32 minus 2 equal 30. 30 divided by 5. For explain the Fermat small theorem, I will use a formula Fermat's called polypolygonals. With the Fermat's polypolygonals formula, it's so simple that I can demonstrate the small theorem with these cards. I have symbolized this formula with these cards. On denominator you can see 1 by 2 by 3 by 4 by 5, and on numerator you can see n by n plus 1 by n plus 2 by n plus 3 by n plus 4. If we develop this formula, how to find the sum of the indices? So I have a trick. If I do that, I have a number of n powered by 5, n powered by 4, n powered by 3, a number of n powered by 2, and n. Okay? But I can't. I don't want to do that now. So it's very complicated. We need a lot of computer program if you have a lot of factors. So I can give to n any value I want. If I give 1 value to n, I obtain 1 by 2. Here we have n plus 2 equal 3, n plus 4, n plus 3 equal 4, and n plus 4 equal 5. So the result is n is 1 by 2 by 3 by 4 by 5 equal 120. It's evidence that Fermat proved his theorem not by each indices. It's too complicated. But what the indices that we are absolutely sure? We are absolutely sure that the first term, if I have factorial 5, is n by n by n by n by n equal n powered by 5. The first term is 1. If I have factorial 7, the first term will be n powered by 7. That shows the first term. We are sure also of the last term, because we have n by 1 by 2 by 3 by 4. What is the link with primary number and factorials? The link is that factorial of a primary number minus 1 is not divisible by this primary number. For example, 1 by 2 by 3 by 4 is not divisible by 5. Factorial 7 minus 1 equal 1 by 2 by 3 by 4 by 5 by 6 is not divisible by 7. In this example, if the last term is not divisible by 5 and the first term also, all terms between the first and the last are divisible by 5, because the sum of all terms are divisible by 5. Here we have 120 minus 1 meaning 24 divisible by 5. I demonstrate that if a number is primary, his factorial less 1 plus 1 is divisible by this primary number. Here you see 24 plus 1, all are multiplied by n, it's still divided by n, divisible by 5. We have the first term plus a certain number of terms equal 1 by n powered by 5 plus a certain number of terms divided by 5 plus 24n. We know that all the middle terms are not divisible by 5 because the last one is not divisible by 5 and the first two, because we must add all terms for having sum divided by 5. So here I have 24n. I can add 1n to have 25n divided by 5 and subtract 1n here to have now 1n powered by 5 minus n is divisible by 5. I say you goodbye and don't forget to go to schemat.com to see all the details of this Fermat's small theorem